In this video, let us look into determining if the pair of linear equations in two variables has a unique solution, no solution, or infinitely many solutions. Most importantly, this is without using the graph. So the first set of equations here we have. So we've got a couple of equations here. 2x plus 3y equals 7 and 6x plus 5y equals 11. So now we need to determine if these pair of linear equations in two variables has a unique solution or no solution or infinitely many solutions. So what we have to do is, the given equation is definitely in the form of a1x plus b1y plus c equals c1 and 2x plus b2y equals c2. Well, we first have to write this like this. 2x plus 3y minus 7 equal to 0 and 6x plus 5y minus 11 equal to 0. This is of the form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So now we need to identify the constants here. a1 equals 2, b1 equals 3, c1 equals minus 7 and a2 equals 6, b2 equals 5 and c2 equals minus 11. So now we have a1 by a2 equal to 2 by 6, which is equal to 1 by 3, and we have b1 by b2 equal to 3 by 5. So clearly we can see that a1 by a2 is not equal to b1 by b2, right? So the given system of equations has a unique solution. Now we've done this in the previous video. We've seen, when is it a unique solution, or when is it a no solution, or when is it an infinitely many solution. Well, this corresponds to unique solution. So the given set of equations, the given set of linear equations in two variables has a unique solution. Let's look into another set of linear equations in two variables. Alright, so here we've got another set of pair of linear equations in two variables. So the first step is to write it like this: 6x plus 5y minus 11 equal to 0 and 9x plus 15 by 2y minus 21 equal to 0. So this is definitely of the form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So let us first find out what is a1. a1 is 6 and b1 is 5 and c1 equals minus 11. And we've got a2 as 9 and b2 we've got it as 15 by 2 and c2 we've got it as minus 21. So now a1 by a2 we've got 6 divided by 9, or simplifying this, 3 goes 2 times and 3 times and 9. So a1 by a2 is 2 divided by 3. And then we've got b1 by b2 as 5 divided by 15 by 2, which is nothing but 5 by 1 times 2 by 15. 5 goes 3 times and 15. So this is again 2 by 3. And then we've got c1 by c2 equal to minus 11 by minus 21, which is equal to 11 by 21. So clearly we can see that this is a1 by a2 equal to b1 by b2, not equal to c1 by c2. So this is the result which we've arrived at. So this indicates no solution. So therefore the given system of equations has no solution, that is, it is inconsistent. It is another word to use to say it's got no solution. So these two equations are checked for the kind of solution that we may get. So this is done. So this problem is done. So this ends this problem. Not the video though. We'll solve another problem. Since these are pretty simple and very easy and straightforward, we can definitely solve another one quickly. So here we've got another set of linear equations in two variables, which reads minus 3x plus 4y equals 5 and 9 by 2x minus 6y plus 15 by 2 equals 0. So we first have to rewrite this as minus 3x plus 4y minus 5 equals 0 and 9 by 2x minus 6y plus 15 by 2 equals 0. So here let's rewrite, this is definitely of the form a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0. So now let us write what is a1. a1 is minus 3 and a2 is 9 by 2. We've got b1 as 4 and c1 as minus 5. And we've also got b2 as minus 6 and c2 as 15 by 2. So now let us find out the ratios. a1 by a2 equals minus 3 divided by 9 by 2, which is nothing but minus 3 by 1 times 2 by 9. So 3 goes 3 times in 9. So we get minus 2 by 3. Now b1 by b2 equals 4 by minus 6. 2 goes 2 times in 4 and 3 times in 6. So we've got minus 2 by 3 again. And then we've got c1 by c2, which is equal to minus 5 by 15 by 2, which is equal to minus 5 by 1 times 2 by 15. So 5 goes 3 times in 15. So again we've got minus 2 by 3. So very clearly, you can notice that a1 by a2 is also minus 2 by 3, b1 by b2 is also the same, and c1 by c2 is also the same. So this says a1 by a2 equals b1 by b2 equals c1 by c2. So we've arrived at the result. So this has got infinite number of solutions. So the given set of linear equations in two variables has got infinite number of solutions. So this ends this problem as well as this video. So what we've done in this video is we've looked into three different sets of linear equations in two variables, and then we've checked out what kind of solutions they may have. The first one had a unique solution. a1 by a2 wasn't equal to b1 by b2. The second one had no solution at all. a1 by a2 was equal to b1 by b2 but was not equal to c1 by c2. And the final one here, we've got a1 by a2 equals b1 by b2 equals c1 by c2, which has got infinite solutions. So thus it ends this video. I'll see you in the forthcoming videos with more problems based on simultaneous linear equations.